that is called as what's the delocalization. Okay, so these are nothing but said to be our you can say that 4 points. Okay. Okay, so we explain paramagnetic behavior of O2 molecule, then say the bonding in electron deficient compounds, metal and intermetallic compounds. Third is nothing but the exact position of the electron in bond, and fourth one is nothing but said to the bonding uh, uh, electron are delocalized. So you can say that what say the delocalization phenomena cannot be explained by say the VT. So now we move towards what say the VBT. So this matter we already discussed. Yeah, already talk about what say the molecular orbital theory. It is proposed by what say the Hund and Mullinken. So these are nothing but two great scientists. Was proposed this theory in 1927. Okay, 1927. So the what are the postulates? So what is postulates means what are the main points over which this theory was viewed. So you can say that this postulates, the first one is what in a molecule the electrons are present in a new orbital called as the molecular orbital. So simply I will tell you what is molecular orbital theory. So we have the atom. So what is the say process? We have first is atom. Okay, two atoms will going to combine. We got what the molecule. Okay, so suppose we have what the atom. So their orbital is nothing but atomic orbital. Okay, another when the atoms are combined, we got what say the molecule. A molecule. So they have the orbital. They are called as the molecular orbital. Okay. So obviously, this is nothing but set with the concept. In simple language, I will tell you what say the atom is having the atomic orbital, molecule is having what say the molecular orbital. Okay, and what this theory mean that there is a combination of the atomic orbital, we got what the molecular orbital. Means the atom will combine, we got the molecule. Okay, this is nothing but a simple concept. And say here next point is what molecular orbitals are formed by the combination of atomic orbital. I already told you was two atoms are combined. Okay, their atomic orbitals are combined. We got the molecule. Okay, molecule is having their own orbital. They are called as the molecular orbitals. Okay, so some of what homonuclear molecules and heteronuclears. I will tell you what a Cl2, then what a H2, and then O2, N2. These are what say the homonuclear molecule. Whereas what is CO2? A CO molecule, a NO molecule is there. They are called as body heteronuclear molecules. Means where we have say the two different element, two different atom. That molecule is nothing but the heteronuclear molecule. Next is what the number of molecular orbitals formed is equal to the number of atomic orbitals undergoing the combination. So I will tell you what say. We have a two atom. Okay, two atom. They having the two atomic orbital. Okay, so when they say reacted. Okay, so we got the molecule. So molecule is having how many orbitals? Two. Okay, so suppose we have a two, you can say that the atomic orbital, they having the two atomic orbital combined, we got the two molecular orbital. As this number of atomic orbitals will combine, we got the same number of the molecular orbital. Two atomic orbital will going to combine, we got the two molecular orbital. Okay, suppose three atomic orbital will combine, we got the three molecular orbital. Four atomic orbital will combine, we got the four molecular orbital. Means as the number of atomic orbital will combine, we got the same number of molecular orbitals. Okay, so this is what say. Then what this is what say the much more important point. I will tell you this point with the help of what say the diagram. Okay, yeah, this one. So see here the Lco approximation. What is Lco approximation? I will tell you. Say it is nothing but the linear combination of the atomic orbitals. So this is what say the linear combination of the atomic orbital. So see what in case of what say the VBT, have you explained? Have you I thought heard about what say the hybridization concept. So what is hybridization? Atomic orbitals are combined. Due to the hybridizations, we got what the hybrid orbitals. These are called as the hybridization, mixing and recasting of atomic orbitals to give what say the same number of hybrid orbitals. That is called as the hybridization concept. In case of VBT, the hybridization will be take place, and here in case of molecular orbital theory, Lco approximation will be take place. That will be called as the linear combination of atomic orbital. Atomic orbitals are combined. How? Due to the linear combination. And what we got? We got the molecular orbital. Okay, so we have so many points over here, but I thought you can't understand this. So I will tell you by just say the molecular orbital diagram. Yes. So this one is what concept I have already told you, but some of you, they do not understand what do you mean by this. Okay. So we goes toward this point here. Yes. So here we explain the formation or its construction of the molecular orbital diagram of O2 molecule. So here this is nothing but said to be the one hydrogen. Okay, this is what say the another hydrogen. Have you listened me? My voice is audible to you?
Yes, sir.
Okay. See, so these are nothing but said to be the first hydrogen. This is what say the another hydrogen. Okay. Next, this is what said to be say the energy axis. Okay, this is the another energy axis. Same way you have to draw this diagram. Huh? That's why I will make this animation. Same way you have to make this diagram. This is first hydrogen. This is what the energy level of first hydrogen. This is second hydrogen. This is nothing but the energy of the second hydrogen. Then third, yes, this one is nothing but the energy level. Okay, so we have to put the orbital over here. So this is what said to be the energy level. This is the energies increases from vertically upward. Okay, from here to here energies increases above. Okay, the next, yeah, these are nothing but said to be the orbital. So we know that the electronic configuration of hydrogen is nothing but the 1s1. Okay, how many electrons in one orbital? One electron. 1s1 is nothing but the electronic configuration of one orbital, 1s1. So this orbital is nothing but said to be the 1s orbital. This one and that one. One hydrogen here, another hydrogen here. This is 1s orbital. This is 1s orbital. Okay, then 1s1 electronic configuration means each orbital is having one unpaired electron. Okay, so these are nothing but the one unpaired electron. So here we have what say the one unpaired electron. Here is nothing but the another unpaired electron. Now, so we have two atomic orbitals. Okay, so which atomic orbitals? This one is nothing but the atomic orbital. This is what atom. This is what say the atomic orbital. Which atomic orbital is this? It is 1s. Okay, it is 1s. Similarly, second hydrogen, they are having this orbital called as the 1s, and this having what say the one unpaired electron in their electronic configuration. So you know that. Okay, next, what happened due to the LCO approximation? Okay, what is LCO approximation? When two atomic orbitals are combined. Okay, so here we have what say the two atomic orbitals, that is this is 1s, this is another 1s. So that two orbitals are combined. Okay, so when these two orbitals are combined, we got how many molecular orbitals? Two. Okay, so like this is what say the combination. Okay, this is another combination. So when these two orbitals are combined, we got two molecular orbitals like this. This one is what say the bonding molecular orbital. That is called as, yeah, this one is called as the anti-bonding molecular orbital. Okay, and we have what are two electrons. So both electrons are enter over here like this. Okay, so both electrons are enter over here. Okay, so we try to understand these orbitals. This one is nothing but the sigma 1s. Okay, and this one is called as the sigma star 1s. Okay, so we try to explain this diagram. See what LCO approximation means. What see, we have the atomic orbitals like this one 1s. This is what say the another 1s. Okay, these two orbitals are combined according to the LCO approximation. Okay, what is LCO approximation? When say the wave function of two atomic orbitals, okay, so they will combine, we got the two molecular orbitals. So the, which are these two molecular orbital? First one is nothing but said to be this one, which is what the sigma 1s. It is, yes, bonding. Okay, another is nothing but this sigma star 1s, which is called as the anti-bonding molecular orbital. Okay, so when two atomic orbitals are combined, we got two molecular orbitals. Okay, one is bonding, which is situated at the bottom. Which one is this? Sigma 1s, which is situated at the bottom. And this is nothing but said to be the sigma star 1s, which is situated at the upper level of this MOT diagram. Okay, so this one is called as the bonding, and this one is nothing but called as what? The anti-bonding molecular orbital. Okay, so why these are classified into the bonding and anti-bonding? Bonding is situated denoted as sigma. Anti-bonding is denoted by sigma star. Okay, star. Whenever we have seen the star, that is nothing but anti-bonding molecular orbital. So See what, when two atomic orbitals are combined, so two types of phenomena we have seen. Okay, means what, two atomic orbitals we have, they will going to combine via attraction. Okay, so we have two phenomena, attraction and repulsion. Have you got it? Attraction and repulsion. So when two, you can say that when two atomic orbitals are combined, when there is a attraction, so their energy will be falls down. Okay, their energy will be falls down. What we got? We got what, say the molecular orbital. You can say that this one, molecular orbital. You can say that the bonding molecular orbital, which having less energy as compared to this. Okay, see what, this is nothing but the energy axis. Okay, and this having that much of less energy. Why? Because this orbital is formed due to the attraction of this orbital. That's why their energy is less. That is called as what, sigma 1s. Okay, another concept is that when two orbitals, they having the repulsion. Okay, which two orbitals? This one is, and this one is, and there is a repulsion, so their energy will going to increase. Okay, and what we got? We got what, this orbital, that is called as the sigma star 1s. Okay, that is called as what, the sigma star 1s. So okay, so two types of orbitals we got over here. Okay, that is what, a sigma and sigma star. So in this way, when two atomic orbitals are combined, we got the two molecular orbitals, out of which one is bonding molecular orbital, which is formed due to the attraction of two atomic orbitals. Okay, which is denoted by, say, the sigma 1s over here. Okay, over here only. Okay, another concept, when there is a repulsion in between the two atomic orbitals, we got what, say, the anti-bonding molecular orbital, which is denoted as what, say, the sigma star 1s. Okay, so this is nothing but said to be the molecular orbital diagram of H2 molecule. Okay, I will repeat it. See what, at this side, this is one hydrogen, which having electronic configuration 1s1. This is 1s orbital, and this is what, one unpaired electron. At the same side, we have second hydrogen. Okay, this is 1s orbital. Okay, and they're having what, say, the unpaired electron, this one. Okay, so when this two atomic orbitals undergo the LCO approximation, okay, LCO approximation, so what happened? Two types of phenomena will observe. So the first phenomena is nothing but the attraction of two atomic orbitals. What we got? We got the bonding molecular orbital. They're having less energy as compared to the that particular atomic orbital. Another concept is nothing but there is a repulsion. Okay, there is a repulsion. And there is a repulsion, so we can say that their energy will going to increase. And what we got? We got the anti-bonding molecular orbital, that is denoted by the sigma star. Okay, so finally, when we got what, this orbital, that is what, say, the sigma, that is bonding BMO. Okay, combinedly these orbitals are called as the molecular orbitals, because these orbitals belongs toward the H2 molecule. These orbitals are nothing but say belongs to the H2 molecule. Okay, and these orbitals belong to what, say, the only hydrogen. That's why they are called as the atomic orbital. Okay, this is what the atomic orbital, and these are called as the molecular orbitals, because these orbitals belong to what, H2 molecule. Okay, now when we construct this, so we have two electron. Okay, so one electron in this over here in 1s of one hydrogen, one electron in 1s in another hydrogen. So we have two electrons. Okay, so now we have to fill these two electrons into this molecular orbitals. Okay, so the electrons can be filled in this orbital according to the three concepts of inorganic chemistry. Okay, first concept is what, above principle. Second concept is nothing but said to be the, you can say, the Hund's rule, and third is nothing but the Pauli's principle. Okay, so say what, according to the above principle, we have to say fill this electron in such orbital which having less energy. Okay, means we have to start the fill up electron from the less energy to the higher energy. So which orbital is having less energy? That sigma 1s, so that we can put both electron into this orbital, because this orbital is having capacity of what, 2 electrons, so that we can put both electron in this orbital, and that electron is nothing but called as the bonding electron in what, H2 molecule. One hydrogen here, another hydrogen here, and in between that, this is nothing but said to be the say the electron density. So how could we know that where the electron density, where the bonding electron is exactly present? So see, I will tell you. See what, when you measure the distance of this electron pair from what this to this, see what, these electron are exactly present over here in between what, two hydrogen atom. So we can locate the exact position of this electron, means where they are present. So they are exactly present at the center of gravity. Okay, that phenomena is not given by the VBT, means VBT fails to explain the exact position of the electron in the bond. But here, in case of what, say this molecular orbital theory, they can exactly locate the position of electron in bond. Here, in case of the H2 molecule, it is an homonuclear molecule. Electrons are exactly present at the center of that bond. Okay, so this is nothing but said to be the construction of the you can say that the molecular orbital theory of H2 molecule. So how to construct, I will repeat it. Okay, so these are nothing but said to be the two hydrogen molecules. Okay, the one line energy axis, another energy axis of second. Yeah, this one. These are nothing but said to be the position of the orbital. Then each having what, say the 1s orbital. So we have the 1s orbital. This 1s orbital each having what, say one unpaired electron. We can write down one unpaired electron like this. Then LCO approximation is there. They can combine through the LCO approximation. They can form two molecular orbitals, out of which one is bonding molecular orbital formed due to the attraction of the AOs. AOs means what? Atomic orbitals. MOs means what? Molecular orbitals. We can use that terms. MOs. MO means molecular orbital. AO means atomic orbitals. Okay. So these two orbitals, they can combine through this LCO approximation. Okay. So via attraction, they can form BMOs. And via, you can say that BMO means bonding molecular orbital. ABMOs means what? Anti-bonding molecular orbital. So you have to learn this term. Okay, you can repeat it again and again so that you can have it. Okay, so another, due to the repulsion, they got what? Yeah, bonding. This is what bonding molecular orbital, which having less energy, formed due to the attraction of the atomic orbitals. Another is the anti-bonding molecular orbital formed due to the repulsion. Okay, this is nothing but said to be the bonding. Okay, yes, this is sigma 1s, this is sigma star 1s. Okay, yeah. So we move towards what, say the exact you can say that the position. Okay, exact position of what say exact diagram of what the molecular orbital. Okay, so see here, each hydrogen is having what, say the 1s. Okay, 1s electronic configuration. Okay, so this is what, say the molecular orbital diagram of 1s. So this is what, say the one hydrogen which having 1s you can say that the electronic configuration having one unpaired electron. This is the another hydrogen atom. Okay, and when they say undergo the LCO approximation, so what happen, they can form what, say the two molecular orbital, that is what sigma and sigma star. Sigma is nothing but the bonding molecular orbital, which is abbreviated as BMOs or sigma. Okay, another is nothing but the anti-bonding molecular orbital, which is abbreviated as sigma star HH. Why? Because they can form due to the combination of two hydrogen. That's why we can write the hydrogen, hydrogen, hydrogen. Okay. So here you can say that what, when these two atomic orbitals, that is what a 1s, they say if there is a attraction phenomena, means okay, when there is a attraction phenomena, so we got what, the bonding molecular orbital having such type of shape. Okay, so we can say that the stabilization due to the bonding. Why stabilization? There is a attraction. There is a attraction. When there is a attraction, the energy will be lower down. Okay, energy कमी होते, त्याच्यामुळे ते खाली येते. Okay, म्हणजे see here, means what, this sigma orbital is having the less energy as compared to the AOs. So we can say that the stabilization. What is stable? ज्याची एनर्जी कमी राहते त्याला स्टेबल म्हणतो आपण. ओके, ज्याची एनर्जी जास्त राहते त्याला आपण अनस्टेबल म्हणतो. ओके, so when these two hydrogens, they combine say through the repulsion. Okay, repulsion phenomena, when there is repulsion, okay, so their energy will be increased. कसं असते, जेव्हा माणसांमध्ये चांगले रिलेशन असतात तर तेव्हा शांतता असते. सो वी कॅन से दॅट व्हॉट दी एनर्जी इज लेस. ओके, जेव्हा त्यांच्यामध्ये समजा भांडण होतात तर मग तिथे एनर्जी वाढते. सो इट इज अनस्टेबल. ओके, सो दिस इज नथिंग बट केस, मीन्स व्हॉट, दोन हायड्रोजन जेव्हा त्यांच्यामध्ये अट्रॅक्शन मित्रता होते, सो वी कॅन से दॅट एनर्जी कमी होते. जेव्हा समजा काही भांडण होतात तर त्याची एनर्जी काय ते वाढते. ओके, सो दिस इज व्हॉट्स द कन्सेप्ट. So this is what's said to be one hydrogen, another they will what combine through what's the attraction. We got what this, that is what the BMOs, bonding molecular orbitals. Another is nothing but say antibonding molecular orbitals formed due to the repulsion of the EOs. Okay, and finally both electrons are enter in here. Okay, so we have to discuss what this term that is called the MO electronic configuration. Okay, see, so we got two types of electronic configuration. That is what say the electronic atomic electronic configuration and molecular electronic configuration. So what is atomic electronic configuration? This one, see, H1, okay, which having 1s1. This is atomic electronic configuration. H is what atom. They having what such type of electronic configuration. Another is what the molecular electronic configuration. So here is nothing but said to be H2 molecule. Okay, they have what is the sigma 1s2. So how to write down this? See here, this is sigma. Okay, which orbital is this? 1s, because it is formed due to the combination of 1s 1s. So we can nominate it as sigma 1s. Okay, how many electrons we have? 2. So here we can write down sigma 1s2. Okay, and here is nothing but sigma star 1s. So sigma star 1s, but we don't have electron here, so that's why it is vacant. Either electron nahi hai. So again it is vacant. So either we can write down what 0. You cannot write down, but you have to write down it because we have two orbitals. So here what a sigma 1s2 comma sigma star 1s. You can write down 0 over here. This is what say the H2 molecule means, the molecular electronic configuration of the H2 molecule. So we have a next you can say that important concept is nothing but a bond order. Okay, so what is bond order? And then next I will tell you what the nature, paramagnetic, diamagnetic nature. See what? This is what say the H2 molecule. Okay, so you forget about what this side. Okay, so you just consider what this side. See, this is what the central side is what the H2 molecule. Okay, and this is nothing but the hydrogen atomic. These are what atomic orbitals. Okay, and this one is nothing but the molecular orbital. Okay, this one is molecular orbital. So see what here we have what two orbitals. See here, say sigma 1s2, another is what sigma star 1s. Okay, how many electrons we have combined? Only 2 electrons, and they are present in the sigma 1s. So either we have the unpaired electron. Yes, we have an unpaired electron. No, what is unpaired electron? Unpaired electron is a single electron. Okay, but we have only 2 electrons and they are paired. See what here? This is what's the paired electron. Okay, and they are present in what's the sigma 1s. You can say that sigma 1s2. So this molecule is what the diamagnetic molecule. Okay, what this H2 molecule is called a diamagnetic because they don't have unpaired electron. Okay, if they have the single electrons, we can say that it is paramagnetic. If they have a single electron, म्हणजे ज्याच्याकडे सिंगल इलेक्ट्रॉन अगर असला त्याला आपण पॅरामॅग्नेटिक म्हणू, आणि ज्याच्यामध्ये सिंगल इलेक्ट्रॉन नसल, पूर्ण पेअर्ड असणार, तर त्याला आपण काय म्हणणार? डायमॅग्नेटिक मॉलिक्यूल. सो दॅट मॉलिक्युलर ऑर्बिटल थिअरी विल ऑल्सो एक्सप्लेन the magnetic behavior of molecule, magnetic state of molecule. Okay, means what if it is paramagnetic or diamagnetic. So in this way the molecular orbital theory will explain what say the paramagnetic as well as what's the diamagnetic. Another concept is what a bond order. Okay, bond order. What is bond order? So see, suppose in case of what the H2 molecule, how many bonds we have? Only one. Hydrogen bond hydrogen, only one bond, that is sigma bond. Okay, so their bond order should be 1. In case of what say the Cl2, we also have a one bond, Cl single bond Cl, we also have the bond order is 1. In case of the oxygen, okay, in case of the oxygen the bond order is 2, because in case of the oxygen we have 2 bonds. The below one is what sigma bond, upper is nothing but the pi bond. Okay, so that bond order can be determined with the help of the molecular orbital theory. So they have some formulas, so I will tell you. Okay,